Hello and welcome to this video recording on the Sophos XG firewall. So today I'll be talking about and I'll be demonstrating how to configure OSPF routing across an IPSEC tunnel using the Sophos XG firewall. So the method that I'll be showing today, it's something that will work between two XG devices if you have two XG devices. It's also something that will work between an XG device and a third-party network device as long as the third-party network device supports IPSEC VPN and supports GRE tunneling. So first of all, a quick disclaimer. So this is a configuration video and I'll be demonstrating how to configure this. And this is not a deep dive into OSPF. It's not a deep dive into IPSEC VPN and how it works. It's not a deep dive into the inner workings of GRE tunneling or firewall technologies. It's just a basic configuration video. And here are the steps that we'll be going through today. Also, I would like to quickly introduce you to um, the infrastructure that we'll be using today. So as you can see, it's a basic infrastructure where we have a LAN network and then public network on two sites, one the Lightbulb Corp site and the other is the Acme Corp site. And then what we'll be attempting to do is for us to be able to use OSPF across an IPsec tunnel between these two sites. So let's get right into it. Step number one. The very first thing that we need to do, if I bring up my notes again, the first thing that we need to do is we need to configure a GRE tunnel. And as time goes by, you understand why we need to do that. So if we just go and configure an IPsec tunnel, you can't get OSPF to work. Many people don't realize that when many companies or many organizations say things like, yeah, you can just create an IPsec tunnel and get OSPF to work across it. No, it doesn't just work that way. In the back end, it's either you're using GRE tunneling or you're using something called VTI, Virtual Tunnel Interface, which is very popular. So either you're using one of both, and then that layer you layer on top of that IPsec VPN. So that's the very first thing that we'll do is we'll configure GRE tunneling. So just a quick basic introduction to what GRE tunnel is. So GRE tunnel is just a generic, and the meaning is generic routing encapsulation, but it's just a generic encapsulation tunnel method. So in other words, if I'm passing the traffic, let's say between this site and this site, it's just going to add an additional header and send it across to this site. It's not going to encrypt it, it's just going to add an additional header. And it's one of the reasons why um, it's very good for routing protocols across sites, but then it doesn't provide security, which is why we want to layer on top of that IPsec to provide that security. So first thing, let's configure this on the XG. I will explain this command quickly. So here is the command, because you need to do this from the backend on the XG that you use to configure the GRE tunnel. It's a single line and I'll explain what this talks about. So it's a system GRE tunnel add and then name. Then you specify the name of the tunnel. So this is something that you can give it any name that you want. Then you specify the local gateway. Local gateway means the public facing port of the XG appliance. So like in this case, the local gateway will be my port 7, which is the port that's public facing on my XG appliance. And in this case of Acme Corp, the local gateway will be also port 7, which is this port that's facing the public. Let's continue. So port 7, and then remote gateway will be the public IP address of the other side that I'm connecting to, which in the case of the Lightbulb Corporation, the public IP address of the peer that I want to connect to is 192.168.20.2. And it's going to be vice versa the other way. And then I have to specify a local IP. Think of a local IP as kind of like a virtual interface within the appliance itself. And as you can see here, labeled in the diagram, that you have to have like kind of like a virtual interface that GRE will be using. So that's created on both sides. It's created on this side and it's created on the other side. So in the case of the command that we're using to create this tunnel interface, we have to specify what the local IP that we want to use for the local virtual tunnel and then the remote IP that we're going to be using for the remote virtual tunnel. So that's all all this depends on the subnetting design of your organization. So I'll do this on both the Lightbulb side and I'll do the reverse on the Acme side. So what I'll just do is I'll copy this command and I'll go to my XG. First thing I'll do actually is let's log into the shell. So this on the Acme side. And what I want is option number 4, which is the console. And I'll do the same on the Lightbulb side. And again, I'll specify number 4. So I'm on the console. I'll paste in my command. And then we'll have a tunnel. Oh, no, that's not what I wanted. Let's get the right command. Paste that command in there. Enter successful. So I'll paste the reverse command on the other side to create the tunnel. And let's go on the side of Acme. Just expand this a bit. And that's all done. If I do system GRE, the XG has a useful inline help that you can use. You can use question mark and it will show you the options that you have. System GRE tunnel, and I can do a show, and it will show me the tunnel that I currently have configured on the Acme side. You can see the name, the local public facing port, the remote public IP address, and the local virtual tunnel interface, if you want to call it that, and then the remote virtual tunnel interface on the other side, all set up in this case. So what I should be able to do, I'll bring up another session. And in this case, I'll use option 5 to go to device management and option 3 to go to the advanced shell. So what I'll try to do is I'll try to, from the Acme side, I'll try to ping from this Acme side here, from 192.168.5.2, I'll try to ping 192.168.5.1, and then we'll see if that works. So ping 192.168, actually I'll just ping itself first, .5.2, make sure that that's working. Yeah, I can ping itself. Then if I try to ping 5.1, I expect this to fail, by the way, and I'll explain why I'm showing you this. Oh, that's successful. Maybe I expect it to fail from the other side. So let's go do it from the other side. So that's successful, which is fine. And I'll show you what I mean if I go to the other side now. Let's log in into this. And advanced shell. And if I do ping 192.168.5.1, make sure I can ping itself. Yeah, it can. Can it ping the other side, 5.2? This failed. So I'll explain this to you. So the reason why this failed is number 3 in my notes that I've got here. So the ping test will fail because there typically is something called local ACL on the XG appliance that allows certain protocols to the appliance itself. So it's something that I enabled one way, but I've not enabled the other way. It's something that you have to enable both ways if you're going to be doing ping test both ways. So I have to go enable ping on the other side, and I'll show you where to do this. So if I go back, so the Lightbulb side is okay. It's the Acme side that I've not enabled this on. So if I log into admin, and the configuration is on the system here, on the administration, and on the device access, and you can see ping is enabled on the LAN and WAN interface, but on the VPN interface, which is where the GRV tunnel, oh sorry, the VPN zone, which is where the GRV tunnel is, and ping is disabled. So if I enable that and apply that, and then if I go back to my Lightbulb side, I should be able to ping the other one now. Yep, and that's successful now, which is good. So just to show you the reason why you just don't want to leave it this way and just say, yeah, I've got GRE working and that's it. It's usually you're going to be using IPSEC VPN, but then you're going to be using GRE for like the routing protocol side of things, and then IPSEC will provide in the security side of things. So I'll do a quick Wireshark capture on this, and I'll stop it after. So I'll just do a quick capture and I'll say ICMP. So I'm just capturing on the ISP side of things here. So I'm capturing from the ISP side of things, and I'll do another ping and let's see what I see. So from the ISP side of things, look at what I'm seeing. I'm seeing this packet, and I think I can stop it now. Yeah, I'm seeing this packet go through, and if I expand this and I go down, you can see basically it's got two layer 3 information. So you can see the original packet, which is from my virtual interface on one side, going to the virtual interface on the other side. But then GRE has added its own encapsulation on top of that, which is another layer 3 encapsulation, which is the public IP of the originating XG appliance to the public IP of the destination XG appliance, and that's layered on top of that. But you can see that this is completely unencrypted going through and the internet. This is probably not what we want. Even if we're just using this for routing, this is probably not what we want. So, but basically there's a tunnel between these two sites now. And if I wanted to actually, I can go and start adding routes to GRE and that will all work, but that's not what I want. So what I'll do is I'll close this and I'll stop my capture. And then I'll move to the next step. So the next step is we want to create an IPsec tunnel. So what we've basically done is we've created this black line here, which is the GRE tunnel between these two, totally unencrypted. But then we want to lay on top of that the IPsec tunnel. So whenever we're doing like the OSPF routing, it goes through, it's going to use the GRE tunnel. But then for the security part of things, it's going to go anything I'm sending to this other site, I've got to send it to IPsec so I have that security to it. So let's go do that quickly. So yeah, jump onto the other site. So I can stop this now. Okay. So first thing that I'll do is I'll create a custom IPsec policy. Go on the VPN and I'll go on the IPsec profiles there and I'll just create a custom one. I'll call it GRE policy and so all this it's not like a written rule that you have to select this. It's just me selecting this based on what I want for this environment. You can select whatever combination of configuration that you want based on maybe your organization policies. So I've got that. I'll disable dead pair detection. I'll select the same protocol set here. And I'll set that to 14,400. And I'll save this. So it is on the light bulb side. I'll add my connection on the light bulb side. So I'll call this light bulb to Acme. Change the connection type to site. I'll select the GRE custom policy that I just created now. And I'll leave this as respond. I'll enter in my pre-shared key. For my local endpoint, I'll select my WAN interface. For the remote, I'll enter the IP address, public IP of the remote appliance. So 192.168.20.2. So here's one other place that I usually see people make a lot of mistake. Is what do you configure for the local subnet here? Because typically if you're just using IPsec, without when you're not trying to do OSPF routing or anything. You're going to specify your local LAN. You're not going to specify that in this case. That's not what you want. Because you don't want to be specifying this going through IPsec statically like that. That's why you want to use OSPF. So that's not what you're going to specify. Instead, what we'll specify, and get this very, very carefully, what you're going to be specifying as the local LAN and the remote LAN are the public IP addresses of both sides. So on the light bulb side, what I'll be specifying is the public as the LAN, as the local LAN is the public IP address of this XGA. And what I'll be specifying as the remote LAN is the public IP address of this. So in other words, what I'm saying is, hey, you're going to be using GRE for like all this routine communication going between these two. But when you want to send them over, anything going from this public IP to this public IP, don't just send it. I want you to give it that security using all the features that IPsec provides. So GRE will do its bit, and then IPsec takes over and then provides the security, gets it to the site, in which case GRE takes it back, and then um, the rest goes as normal networking goes. So let's go back to that. So for this local subnet, I'll create a new object. I'll call this the lightbulb one. I'm on the lightbulb side, and I'll give it the public IP address of the lightbulb site, which is 192.168.20.1. And I'll save that. I'll save this, and that's configured here. On the remote LAN side, I'll specify the public IP of the Acme side. I'll call it Acme 1 interface 192.168.20.2, and I'll save that. And that's there, and then I'll save this. So at this point, this connection is currently deactivated and not enabled. That's all right. I'll go to do the same on the Acme side of things. So let's go on the VPN, add my new custom profile. Specify the same. Disable that peer detection. I'll specify the same thing here. I'll change my timers to be the same, which is 86,400 I think I used. Yep, it's 86,400 I used for the first one, which is a day, 24 hours. I'll specify 14,400 over here. So just confirm that it's all identical. Yep, that looks okay to me, and I'll save that. And then I'll go on the connection and add a new connection. I'll call this Acme to light bulb. Again, site to site, select my custom policy, set my pre-shared key. Local interface, I'll select that. Remote interface 192.168.20.1. Local subnet, let's go create new. In this case, that will be the Acme 1 public IP, so I want. So 192.168.20.2 is the address, and I'll save that. And for the remote, I want the public IP of the lightbulb site, so I'll call that lightbulb 1 IP, which is 192.168.20.1, and I'll save that. And I'll save this. So at the moment it's currently not activated, so I'll make this active on this side, and I'll do the same on the side of the active. Is it active on this side too? Yep, active on this side too. and then I can trigger the connection. And that's successfully connected. I can see my green radio there. I can refresh this by clicking on IPSEC connection, and that's back. So that's all fully connected now. Let's see if we can do this. So if I do another Wireshark capture, and I'll filter for ICMP. Let's ping the other side from here. But look at this. I'm no longer seeing ICMP like I was saying earlier. You know, before I was seeing the ICMP in plain text, I'm not seeing this. But still my pings are successful. So what's going on here? If I change what I'm filtering from ICMP and I change that to filter for ESP IP protocol 50 packet, you see that that's incrementing as my pings are going. That's incrementing. If I stop my ping, I go back, it stops. It's 193. It remains at 193. I go back, start my ping again, and I go back, and that starts incrementing again. So what's happening is now that's GRE now working together with IPSEC. GRE providing that tunnel that we're able to move our routing protocol communications across between the two sites, while IPSEC is providing that communication because this packet now has GRE inside it, but you have no idea what's inside because it's all encrypted by IPSEC. Great stuff. Okay, moving on from there. Um, so, which is what I've highlighted here. So all the things I've highlighted in maroon, make sure you pay attention to them because those are areas that I've seen people make mistakes. So make sure that you enable your local ACL for ping if you're going to be doing ping tests. Make sure that when you're specifying your local and remote WAN, you specify the WAN IP addresses, not what you normally select in IPsec, which is the local LANs. So now we move to step number 3, which is where we actually go and configure OSPF. So let's go ahead and do that. So I can stop this packet capture now. And I can stop it from within GNS3. Yep, that's stopped now. Okay, so now let's go and it doesn't matter which one we start from. We can start from Lightbulb, we can start from Acme. We go under configure on the routing here and go under OSPF. First thing that we'll have to do is we'll set the IDs for them. I'll give them the public IP as the ID, which in this case 192.168.20.1. And once I apply that, it's gonna basically enable OSPF once I apply the router ID. Then I configure my network statement in OSPF, which in this case will be the interfaces that I want. So in this case, on this side, I will configure the GRE tunnel interface. I'll put that in OSPF. I'll put this interface also in OSPF. I won't be going into all the other things like passive interface and all that. I'll just do the basic. So let's go 192.168.5.0, which is my tunnel interface, and I'll specify /24. It's very important that you specify this way. I'll just put everything in area 0. No need to get complicated for now. I'll save there. And I'll add the other interface, which is the LAN interface, which is 192.168.11.0. And that's /24. So for those that don't know, like when you're configuring network statements in OSPF, they do two things. They specify which interface that OSPF will be enabled on because OSPF is per interface, but they also specify which networks, not necessarily like the networks, but because they specify which interface OSPF will be enabled on, that affects which networks will be advertised. So if you've not enabled OSPF on an interface, that network on that interface won't be advertised in OSPF. by default, I should say. So 192.168.11.0/24, add that into OSPF area 0 also. And that's done. So I'll go to the Acme side and do the same thing that I did, which is go on the routing, enable OSPF, and add the interfaces that I want. So 192.168.20.2, apply that. Yep. And then I'll add my network statement, which is again the tunnel interface 192.168.5. I'll give it .0/24. Put it in area 0. Save that. And I'll add the local LAN interface or the local LAN on the Acme side, which is .15.0/24. So 192.168.15.0, specify that to be /24, and area, so everything is in a single area 0. So that's done. And then the other thing I want to show you is on the XG. I'm on the console now. If I exit the console and go back to this main menu on the command line, so you have this option number 3, which is for root configuration. So I know many people know the XG as kind of like a security appliance, and it is. It's got very, very great features for protecting the network. And even extending things for even helping to protect the endpoint and stuff like that. But it's also like a powerful network device. It has like some really advanced routing features that you can use. So for example, if I go on the root configuration here, which is option 3, I have the option where I can configure unicast routing option 1. If I select option 1, and then you see this option where I can configure OSPF. If I select that, which is 2, I come to this, I can go to my enable, enter, and I can do a lot of stuff from here. So for example, I can show my IP OSPF interface. I'm on the Acme side. My GRE interface is called Acme GRE. And I can see that this interface is up, OSPF is enabled on the interface, what the hello timer and the dead timers are. I can see all the information here in backend. I can do show IP OSPF database. I can see my database. I can even enable debugging, which is one of the things I'll be doing in this case. So now I have OSPF enabled on both of these. I've added this tunnel interface and this LAN interface, and I've added this tunnel interface and this LAN interface. But let me see if I have my neighbors, my OSPF neighbors. So show IP OSPF neighbor, anything? Nothing, absolutely nothing. Okay, let's try to get more information. I'll have these two windows layered on top of each other. So let's go layered window and this layered window below it. Okay, so what I'll do is I'll just tell the OSPF log. Yep. And one thing I want to find out is I've enabled OSPF on this interface. Is it sending out hello packet trying to do neighbor discovery? Let's find out. If I do a debug OSPF packet, I can do hello, but I just do all and send. So what am I sending? I want to see this on the log. So if I enable this, let's see. Yep, and you can see instantly I'm sending out hellos from my virtual tunnel interface and from my LAN interface. There are ways that you can enable passive interface if you need to, but I won't be going into that now. So but you can see I am sending out hellos, which is fine. So I'll remove that debugging. Always remove debugging once you confirm what you need to confirm. And then I'll move this down a bit and see. Let's go down and I'll go back and I'll enable debugging, this time not for send. I'll enable debugging for received packet. Sorry, I have no in front of that. I'll remove that. say debug OSPF packet all that I'm receiving. And I say nothing. I'm receiving nothing. But I know I'm sending the packet, but I know I'm not receiving anything. Okay, what about am I receiving anything from the other side, which is 192.168.5.1? If I do a TCP dump dash I any and I'll say host 224.0.0.5, which is one of the multicast addresses that OSPF uses, and instantly I can see that uh, I'm sending out OSPF hellos from my tunnel interface, but I'm also receiving, I'll stop this now, I'm also receiving from 5.1 from the other side, I'm receiving OSPF packet from the other side. Yet, if I go to show IP OSPF neighbor, I've got no neighbor relationship, no adjacency formed. What's going on? That leads me to the next point here, which is, so all the points I've highlighted in maroon, they have for a reason. The main reason is these are the areas that I've seen over time that people make mistakes in. So this particular area is hellos have been sent. Yeah, in this case I said but not received. That's not accurate. It's they've been received, but I'm seeing nothing. So what's going on is I have local ACL again. That's the issue. I have to enable dynamic routing on the local ACL. So let's go back to do that. So if I go back to this and I go under administration and under device access again, and I can see that I have dynamic routing here. I have to enable dynamic routing on my VPN interface. So in order to show you, so I think I still have debug going on for received packet. Let's see if I still have debug going on for received packet. So yep, I still have debug going on. I'll just apply it again in case. Okay, and I'll go ahead and enable this, and then I'll go back. So tick dot, enable dynamic routing on the VPN zone. I applied that, and once it's applied successfully, I'll minimize that, and let's see if we're now receiving the OSPF hello. Instantly, you see we've successfully received it on this side. So all I just need to do is to just go do it on the other side also. You can see instantly I have a neighbor, but I need to go do it on the other side also. Otherwise, the other side we still have a problem. So I go under administration, device access, and enable dynamic routing on the VPN zone, and apply. I'll just give it a short moment here. So for this one, let me exit, go to option 3, option 1, option 2, and enable show IP OSPF neighbor. And here we go, I've got OSPF full neighbor relationship formed between these two, and that's going over IPSEC. So that's OSPF working fully across site going over IPSEC. It's really cool stuff. So let's go, but again, remember, because that's the other part that many people forget to mention, it's been assisted by GRE, right? If I go exit on this, okay. So if I just do on the XG, let's see what's in the routing table. So I'm on the light bulb side. Let me see if I'm able, so I'm on this side of things, light bulb side. Let me see if I'm able to see information about this 192.168.15.0. I've not specified this statically anywhere. Let me see if I've learned about this network from my neighbor, which is across an IPsec tunnel. So let's see if I do IP road show, and you can see 192.168. Am I on the, yeah, I'm on the side. So 15, yeah, here we go. 192.168.15.0, and that's saying I've learned this from OSPF, but that's pointing to my GRE interface, that's where I learned it from. And if I go on the other side of things, So on this side, I'm able to see 15.0. If I go on this other side, I should be able to see 11.0 also length. So if I go to the other side quickly, Acme side, and I do IP route show, and instantly I can see I've length 11.0. And for you to know, I can start playing around with things now. I can add more interfaces to OSPF on the other side. So now I know about 11.0. But the truth is, on this other side, I have more than 11.0 network. I also have two other networks, which are 192.168.12.0/24 and 192.168.13.0/24. I have these other networks on this side. So I can write network statement for this, add them into OSPF, and this side will instantly learn them. Let me quickly demonstrate that. So if I go to the side of the light bulb, and let's go on the routing on the OSPF, and I'll just add network statement for 192.168.11.12.0/24, and I'll just put it in area 0 also, and I'll also add 13.0/24 also, and I'll add this into OSPF. So this on the light bulb side, I've just added these two new networks into OSPF. And then if I go to the other side and I do my IP route show again, look at that. So in the past, I only had 11.0. Now I have 12.0 and 13.0, and that's pointing to my GRE tunnel interface. So OSPF is all working, but now can my host ping one another? Because this is the final step. Can I ping from this host now to this other host? Can they talk to one another? So if I go back, so IP config, I'm on 15.10. Can I ping 11.10 on the other side? Ping 192.168.11.10. No, and that's expected. The reason why that's expected is the next step. You may have to make sure that you configure your firewall rules, because now you've got routing all configured between all of them. Doesn't mean that everything will start working or traffic will start passing. Remember, the XG is more than just a network device. A powerful network device, right? It does like very good advanced and networking features, but it also has advanced security features. So it does a lot of security stuff also. So we need to make sure we configure our firewall rules. So I'll just quickly go ahead and add that. And again, remember what I said, this course is not a security course. Never do this and put this kind of rule in your production environment, except you know what you're doing. So I'll create two rules, LAN to VPN and VPN to LAN. I'll say anything from the LAN zone, going to the VPN zone. I'll remove the identity portion. I'll say allow that, and I'll save that. And I'll basically just clone this, and I'll do the reverse, which is anything from the VPN zone to the LAN zone. And then I'll go do the same on the other side. So in this case, that's VPN to LAN, and I'll change this to anything from VPN, remove LAN, anything from VPN going to the LAN, and the action is any service clone. And I have firewall rules on the Acme side of things. Now let me go over to the Lightbulb side of things and add firewall rules also. So add a firewall rule, and I'll say anything from LAN to VPN to my VPN zone, remove identity, and save that. And I'll do the same opposite. So let's LAN to VPN. I'll go, let's clone that. Let's do VPN to LAN. That's VPN to LAN. Remove that. VPN to LAN. Okay, and clone that, and that should all be good. Yep, so firewall rules now exist. Let's go back to Acme. Let's see, before I wasn't able to ping the other side, and of course I'm able to ping the other side. And can the other side ping me also? So ping 192.168.15.10. In other words, I'm trying to ping from 11.10 to 15.10. So let's make sure that that's working. Yeah, and now that's good. And that's all going over OSPF as I'm removing network, you're learning about it. OSPF traffic going straight across an IPSEC tunnel. So I hope that was useful and informative for you. If you've got any questions, leave them down below in the comment sections. I'll add some very useful links on the Sophos community page. If you've not joined the community page, it's a really great resource that you can use to get answers to different questions. Very, very useful stuff there. So I recommend that, and I'll put some links to some useful KBs below also. So also if you've got like recommendations of videos that you'd like me to make about the Sophos XG firewall or different Sophos appliances, just let me know. If I get time, I'll get to them and make them. So I'll see you in the next video. Have a great week. Bye.